This is Ray's Magnetic Torque Generator 7. I've done some refinements to it and improvements to it. We've increased the power for the little generator output. You can see that it's flashing much brighter than in number 6 that we had earlier. I've changed some of the sidebars. They are now 5/8 instead of 1/2 inch square, 3 inch. And it's very important to place the magnet in that position. If you see that we're looking down the same way here, that the north is here. This side here is not the south. This is in between the north and the south. That's very important to do that. That gave me more power. Okay, we'll go ahead and measure some of those like we did on number 5 and 6. See how it automatically resets. I got rid of that little reset magnet that I had on number 6. See how that's firing now. Okay. Okay, and the same goes as I work on over unity research, I'm looking for more power out than in. So if you have more power out than in, I call that an over unity result. So my output is the force that's coming down on the generator to light the 45 LEDs. My input would be considered what force it takes to engage and disengage my magnets, or my rotor. That would be my input. So here we go. I'm pushing. You can see it's very, very little. I did that in number 5 and 6. So as we spin that around, this is a balancing weight. You can see that it'll come around and it'll automatically reset. So that's a nice feature also. And having this at a 45 degrees spin from what I had on number 6, I gave it more power. So let's see how much power we have now. Okay, we'll take my ounce gauge, and if you remember correctly, I see what the force is. From number 6, we had 8 ounces. That was about 45 quarters. So the force of weight coming down on my generator was 45 quarters, about 8 ounces. Okay, let's see what we have now. We have a new position of the firing magnet. So let's see if that does anything with our force here. And we had 8 from the old style. There's 10. Just about 11. I had 11 there earlier. Depending on your distances here. I was fiddling with the distances earlier. I had it up to 12 earlier. But right now we have about 10 or 11. So the force that's coming down on the generator is between 10 and 11 ounces, which is sufficient, because if you remember the input, it really didn't hardly show on my gauge. There's my 10, just about 10, 11, about 11 ounces or so. So that's the force that's coming down. So we had increase on my forces, and you can tell the brightness of the LEDs that they're flashing brighter than I was on number 6. Let's start her back up again. So the improvements, once again, I increased the thickness of the bar. That held that in better. 1/2 inch probably work. I just put that in there. It was holding it in position a lot better. And this is my neutral principle, which is really important. When there is sufficient coverage of a north-south field, the resultant force is magnetically zero within the iron bar. So let me go ahead and turn that off. So I have a sizable screwdriver here. It has a nice iron or steel end on it. So you would think if you have a magnet there, that magnet, I never did look up, but we could have a pull-off force of 100 pounds or more, and yet the resultant force on there is 0. And that's because the north and the south on this magnet is being covered sufficiently by an iron bar. And when the fields, north and south field, the resultant force will be magnetically 0 within the iron bar. And we can see that that's what's happening there. I'm covering that north-south field sufficiently with an iron bar, and you have the resultant force, which is 0. That allows my flapper magnet to come in and out of firing position and resetting position with very, very little force. So that's my input. And as we could see, that the output, we had like 10, 11 ounces. So we had some good improvements here. We got rid of that small magnet for resetting that I had on number 6. This just works all around better, and we have a little bit more power. And another fascinating little thing, most generators that you see, the faster it goes, the more power it puts out. This is not dependent on speed at all, which is a nice feature. You can go as slow as you want. I went down to 2.5 volts. The other ones were 3 volts, but I went down to 2.5 volts just to kind of go a little bit slower and make everything more visible. So this is a very unique generator, very, very little input, and output is sufficient. And I hope you enjoyed this video and the improvements I did on this. If you'd like to donate to this work, I'd appreciate it, and hope you enjoy your time inventing.